Chapter 2, Hydraulic Systems. Field Manual 5499, Hydraulics, Hydrocores Department, Army Distribution Restriction for public utilities. Distribution is unlimited. Chapter 2, Hydraulic System. Hydraulic system contains and confines the liquid in such a way that either the law of the governing liquid to transmit power to do work. The chapter describes some of the basic system to discuss the components of hydraulic system: store condition, the fluid, the oil reservoir, sump tank, usually serve the storehouse or fluid container, filters, strainers, magnet plugs. Condition the fluid by removing harmful impurities that could clog passages, damage part of the heat exchange with the coolers, often used to keep the oil temperature within safe limit to prevent deterioration of the oil accumulators from the technical source of the stored air energy as the fluid storehouse. Basic system: the advantage of hydraulic system over the methods of the power transmission. Simpler to design. In most cases, the free pre-energized components will replace complicated mechanical linkages. Flexibility: hydraulic components can be located with considerable flexibility. Pipes and hoses and mechanical elements virtually eliminate location problems. Smoothness: hydraulic system smoother and quiet in operation. Vibration kept to a minimum. Control of the wide range, speed and force is easily possible. Cost: high efficiency, minimum friction loss keeps the cost of power transmission at a minimum. Overload prediction: automatic valves cover the system again with the breakdown from overloading. The main disadvantage: hydraulic system is maintaining precision parts that are exposed to the bad climate, the dirty atmosphere. The protection given the rust, corrosion, dirt, oil, deterioration, and other adverse environment. And very important, following the paragraph discuss several of the basic hydraulic system. Hydraulic jack shown figure 2.1, page 2.2. As a reserve system of the valve has been added with the Pascal's hydraulic lever to stroke with a small cylinder with a pump container instantly rising like a large piston actuator at a notch. Each stroke diagram A shows intake stroke. Outlet check valve is closed with the pressure under load. The inlet check valve opens with the flow of the liquid. The reservoir filled with a pumping chamber. Diagram B shows the pump stroking downward. Inlet check valve closing, pressure and outlet valve opens, more liquid pumped in with a large addition to the raised lower and load. Third valve, needle valve opens, which opens the area under the large piston to the reservoir of the load, then pushes down and forces the liquid to the reservoir. Motor reversing system figure 2.2, page 2.3 show the power-driven pump operating reversible rotary motor reversing valve directly fluid to either side of the motor and back. Alright, so you have your pump, atmosphere, reservoir, inlet check valve, outlet check valve, load and actuator. Alright, from the pump through the inlet check valve, and then pump and needle valve, atmospheric pressure, and the weight on the accumulator on the actuator on the load. To reserve to the reservoir, relief of the protect for the system again with the excessive pressure can bypass the pump output with the reservoir pressures rise too high. Open center system. In this system, the control valve spool must open into the center to allow the pump flow through the valve of the return of the reservoir. Figure 2.3, page 2.4 show the system in the neutral position operates several functions simultaneously. Open center system must have the correct connection with the discussed below. But the open center system deficient signal function limited to the multiple functions. One serial connection, figure 2.4, page 2.4. So the open center system series with the connection oil from the pump routed for the three control valves in series. The return from the first valve rotated for the inlet of the second, and so on. The neutral oil passes through the valve. Series return the reservoir arrows indicate that when the control valve is operated, incoming oil is diverted into the cylinder of the valve series. Return of liquid is cylinder directed through the return line on the next valve. This system is satisfactory as long as the only one valve is operating at a time. When this happens, the full output of the pump, the full system pressure is available to the function. However, the more the open one valve operating, the total pressure required for each of the function cannot exceed the system relieving setting. Alright, show the pressure line, return line, the pump, and the tank, suction line, pressure line, return line, motor reversing system. Pump oil returns and the pump runs constantly, doing neutral oil flows through the valves. Tapped oil holds cylinder head, cylinder piston in place. Directional control valve open center cylinders, relief valve full, fixed displacement pump reservoir. Serial parallel connection figure 2.5 show the variation series connected with the type of the oil from the pump arrived with the control valve with the series as well with the parallel of the valve, sometimes stacked with the valve with the extra passages and neutral liquid passages through the valve, and the shape of the arrows indicate that however the any of the valve is operating, the return is closed with the oil with the available the valves with the parallel connection. With two or more valves operated at once with the cylinder that needs the least pressure, will open first with the cylinder with the next least and so on, with the ability to operate with two more valves simultaneously advantage over the series connection flow divider. Flow divider figure 2.6 page 2.6 shows an open center system with the flow divider take with the volume oil from the pump that divides it in between the two functions. From the example of the flow divider managing the sign to open to the left side within case of the both the control of the valves actuated simultaneously with the motor to divide with the oil from both sides with equally by the percentage. With this system the pump must be large enough to operate all functions simultaneously, must also supply with liquid maximum pressure for the highest function, meaning large amounts of horsepower is wasted for the operating of only one control valve. Closed center system pump the rest of the oil is not required for the operate the functional means for the control valve is closed in the center, stop at the flow of the oil from the pump. Figure 2.7 page 2.6 show with the closed center system operated with the several functions simultaneously. Closed center system to have the following connection: fixed displacement actuator pump, fixed displacement pump and actuator. Figure 2.8 page 2.7 show with the closed center system with the pump small constant volume changes with as accumulators. Shows the open center system with series parallel. Figure 5 page 2.5 fixed displacement reservoir relief valve directional control valve open cylinders parallel connection series connection. Cylinders selling single acting control valve flow divider relief valve flex plate displacement pump reservoir open center system flow divider. Alright, we have a tank pump starting two or more oil, valve shifted directing oil as shown, and the oil returns the reservoir pressure, and then one valve is shifted during the direction of the oil shown, pump starts pumping more oil, pressure oil releases piston and load, and for this oil returns to the reservoir. Alright, you have your direction control lines, control valves closed center, accumulator check valve, unloading valve, fixed displacement and reservoir. When the accumulator is charged with the full pressure, the unloading valve directs the pump of the flow of the back to the reservoir check valve with the traps of the pressure and oil in circuit. The control valves operate accumulator discharge oils actuates the cylinder pressure begins with the drop unload of the valve directing with the bottom flow of the accumulator recharge the flow system using small capacity pump effectively operating with a need with only a short time however the function but not only lots of oil with a longer period. Accumulators cannot handle unless the accumulator is very large. Variable displacement pump. Figure 2.9 page 2a show the closed center system with a variable displacement pump with a neutral mode with the neutral oil pump until the pressure arrives with a predetermined level with the preset pressure regulating valve allowed with the pump to shut off by itself with maintaining the pressure with the valve with the control valve with the operating with the oil is reverted with the pump at the bottom of the cylinder. Drop in pressure is called with the connecting with the pump with the pressure line with the bottom of the cylinder called with the pump with the go back to work pumping oil with the bottom of the piston raising the load. When the valve moves to the top of the piston connect with the return line allowed with the return oil from the force of the piston to return the reservoir over the pump. When the valve returns with the neutral oil trap on the both sides of the cylinder, the pressure passage from the pump at the dead end of the sequence with the pump rests the spool within downward position directs oil from the top of the position, moving load downward the oil from the bottom of the piston stem with the return line. Figure 210 page 2.8 show the closed center system of the charging pump which pumps oil with the reservoir variable displacement pump with the charging pump supplies. Shows reservoir of the pump can only stop during neutral. Valve stops oil but oil stops system pressure trapped oil holds cylinder and piston in place. Directional control, that was variable to displacement pump. Directional control valves closed center, variable to displacement pump, charging pump, reservoir closed center system with charging pump. Only makeup of the oil of the required system provide with the inlet pressure for the make of the variable displacement pump with the more efficient return oil system functions and sent directly inlet variable displacement pump because of today's machine with the more hydraulic power closed center system is more advanced. For example, on a tractor oil may be required for the power steering and the power brake for the remote cylinder with a 3-point hitch of the loader with the other mounted equipment. In most cases, each function requires the differential quantity of oil with the closed center system and the quantity of the oil, the function with the control of the line valve side of the orifice and with less heat, but the buildup of the air of the flow divider is necessary comparable to the open center system. On the other advantage of the closed center system are as follows. It does not require a relief valve to cover the pump. It simply shuts off by itself when the standby pressure is relieved. It prevents the heat building up the system. Relief of the pressure for the frequently reach side of the line valve of the cylinders can be tailored to flow the requirements of each function. Reservoir flow is available to use the large pump to ensure the flow of the hydraulic speed at low energy revolutions per minute. With more function can be served, it is more efficient for the function. For the step of the brakes require force of very little piston movement by holding the valve open and standby pressure for the constantly applied with the brake piston. No efficiency loss because the pump has returned to standby color coding. And in this manual figure show the oils conditions of the path are prepared with industrial standard color codes. Table 2.1 lists the colors for the hydraulic lines and passes them many of the figures. Operating pressure red, exhaust blue, green, intake or drain, meter flow yellow. 2-3 reservoirs. Reservoir stores liquid and that is not being used in the hydraulic system. It also allows gas to expel foreign matter to settle out from the liquid. Construction properly constructed reservoir should be able to dissipate with the heat from the oil, separate the air from the oil, settle out contaminants that are in it. Reservoir arrangement that constructed small steel stamping, large cast fabricated unit with large tank show, but the sandblasted off and all welding is complete with a flush and steam clean. Doing so, remove the welding scale left with the hot rolling steel. Inner surface of the end shell be sealed with a paint collab and compatibility hydraulic fluid, non-bleeding red engine enamel suitable for the petroleum oil seals and the residual dirt not removed by flushing or steam cleaning. Shape. The figure 2.11 shows the shape of the design feature of the reservoir should be high and narrow rather than shallow and broad. The only level that should be high possible above the opening of the pumping suction to prevent the vacuum of the line opening with the cover of the vortex whirlpool effect, which would mean that the system is probably tanking in air. The aerated oil will not properly transmit power because of the air of the compressors or aerated oil's tendency to become with the breakdown loose lubricating mobility. Size. Reservoir sizes will vary, however the reservoir must be large enough so that it reserve the oil while with all the cylinders in the system fully extended. The oil reservoir must be high enough to prevent vortex and suction lines opening, and the reservoir must have sufficient space to hold all the oil and cylinders retracted as well, but the allow space for the expansion of the oil is hot. A common size reservoir mobile machine is 20 to 30 gallon tank, but we use for a 100 gallon per minute system. A 10 gallon per minute per tanks. 10 gallon per minute system operates on 2 to 3 gallon tanks because their mobile systems operate intermittently, not consistently. Stationary machine rule of thumb is that reservoir size should be 2 to 3 times the pump output per minute. Large size tank highly desirable for the cooling with large surfaces are exposed to the outside of the transfer of the heat of the oil. Large tanks help to sell out the contaminants, separate air, reducing recirculation. Location. Most mobile equipment reservoirs are located above the pump. This creates flood pump inlet condition. The condition reduces the possibility of the pump. Figure 2.11 should design with the reservoir, suction line, strainer, pump, vented filter cap, baffles, drain plugs, return line, oil level, cleaning out cover. Cavitation condition whether all the available space is not filled with the often metal parts will be erode with the floating inlet. Also reduce vortex tendency, suction pipes, opening location, reservoir effects, heating disposition identified with all the tank walls should be exposed with the outside of the air, moves the hot substance with the cold substance for the heat transfer with the greatest for the very large temperature difference. Reservoir built into the front end loader arms very effective for the transferring heat. Ventilation of the pressurization. Most reservoirs are vented by the atmosphere for the venting opening allowed with the air to leave and enter the spray with the above the oil, the level of the oil goes up, the down maintains constant atmospheric pressure above the oil with the reservoir filled with the cap of the filter element, often used as vent. Some reservoirs are pressurized using simple pressure control valve rather than vented. One pressure control valve automatically lets the filtered air into the tank and prevents the air release for the pressure reaches out with the preset level. Pressurized reservoir takes place when the oil and the air in the tank expand to the heat. Line connects to the pumps and suction, and with the tank return line should be attached with a flange with a weld. The heavy-duty couplings, steering couplings usually are not suitable because they're spread when welded. The suction line connected with the bottom of the coupling should be extended with a weld above the bottom inside with the tool. Residual dirt will not get in the suction line with the tank at the strain with the cleaning with the return line discharge for the tank at the bottom and always below the oil level. Pipe usually causes 45-degree angle flow aimed away from the suction line to improve circulation and cooling. A baffle plate is usually separated with the suction line with a return line causes with the return oil with the circulate around the outer wall with the cooling with the bowl before it gets to the pump again with the baffle plate with about with the 2/3 of the height of the tank with the lower corners with the cut diagram to allow with the circulation that must be large and higher in an area suction line cross section, otherwise oil level between the return suction side of the might be uneven. Baffling also prevents oil and slushing around when the wind machine is moving the large reservoir with the cross baffle to provide with the cooling and preventing sloshing. Maintenance procedures include with the drain and cleaning of the reservoir tank should be declined to the dish, bottom of the fitting with the drain plug, lowest point with the plug. Fitting should be flushed inside of the tank to allow the full drainage on large tanks. Access plates may be bolted into the easy of the removal of the servicing reservoir shall have the sight gauge for the district checking with the oil level preventing damage from the lubrication. The strainers on the pump of the suction line may not require the much maintenance of the element of the filter return line will require regular changing, and therefore the filter should not be inside of the reservoir. Reservoir is pressurized with the compressed air with the moisture with it becoming the maintenance problem. The tank shall have the water trap for the moisture removal should be placed where it can be inspected daily. Strainers and filters to keep hydraulic components performing correctly. The hydraulic liquid must be kept as clean as possible with the foreign matter from the tiny metal particle with normal wear of the valve and the pump. The other components are going into the enter of the system. Strain filter magnetic plugs are even to remove the foreign particles of the hydraulic liquid in effect with safeguard against contamination. Magnetic plugs located within the reservoir even to remove the iron and steel particles from the liquid. Strainers. A strainer is a primary filtering system and the remove the large particle of the foreign material for the hydraulic liquid. Even though the screening action for the done is good for the filter strainer offer less restriction flow. The strainer usually consists of a metal frame and wrapped in the fine mesh wire with the screening element made of the very thickness of the specially processed wire. Strainers are used to pump inlet lines in Figure 211, the bigger page 210, where the pump pressure drops must be kept at a minimum. Figure 212 shows the strainer with through the possible arrangement. Use the pump inlet with if the strainer causes with excessive flow friction pump the two more. Use in parallel the strain pipe and fitting must also be below the liquid level in the tank. Filter remove the small foreign particle with the hydraulic fluid must be effective to safeguard against the contaminants. Filters are located in the reservoir pressure line, return line, any other location where necessary, classified as full flow with a proportional flow. Full flow filter Figure 213 and full flow filter, all fluid entering the unit passive filter element. Although full flow type provides more positive filter action with a greater resistance flow, particularly when it becomes dirty. Hydraulic liquid enters the full flow filter through an inlet part of the body and flows around and shows oil level of the pipes adjoin submerged pump inlet take connection oil level disconnect unit and remove the strainer cleaner. Access open should provide with the strainers may be removed from the cleaning without draining the tank. Hydraulic system strainers. Elements inside the bowl filter and curve lag liquid process through the element in the hollow core, leaving the dirt impurities outside of the element. Filter liquid with the flow of the hollow core with the outlet port outlet of the system. Bypass relief valve allows liquid to bypass the element pass directly through an outlet port with the element that becomes clogged. The filter do not have the bypass relief valve have a contamination indicator, but the indicator works on the principle of the difference of the pressure of the fluid as it enters the filter and leaves the element with the contamination parts of the collective of the element with the differential pressure increases. With the pressure increase, the reaches specific valve indicator pops out, signifying that the element must be cleaned or replaced. 213 shows the full flow hydraulic filter, inlet port, outlet port, head, bypass valve, body, filter element, hole, hollow core, filter bowl. Alright, 2 proportional flow filters. Figure 214 show the filter upper venturi principle in which the tube is narrow throating of the venturi increase with the velocity of fluid flowing through it. Through venturi throat closed with the pressure drop of the narrowest point with the pressure decrease the cut of the suction action from the draw of the portion of liquid drawn down around the cartridge filter element up to the venturi throat when then entering filtering occurs the other than flow direction. Although any proportion of the liquid off filtered during each of the cycle, the constant recirculation of the system eventually causes the liquid to pass to the element, replacing the element according to applicable regulation, doing the following. Figure 214 shows the venturi throat, and then your body and your cartridge and baffle and sediment. Relief pressure, remove the bowl from filter body, remove the filter element for the body using slight rocking motion. Clean and replace the element depending on the type. Replace old O-ring, packings, and basket washers. Reinstall bowl and body assembly to tighten with the body. Successfully check with the appropriate regulations. Specifications. Some filter elements require the specific torque. Pressure the system. Check with the filter assembly for the leaks. 2.5 Filtering material and elements. General class of filter material and mechanical absorbent and interactive and absorbent material. Mechanical fluids contain closely woven the metal screen with the disc of the generally remove only fairly coarse particles. Absorbent inactive filters such as cotton, wood, pulp, yarn, cloth, or resin remove the smaller particles. Some of them remove the water soluble containers of this element, often treated to make them sticky to attract contaminants found in the hydraulic oil. Absorbent activity materials such as charcoal and fuller's earth or clay-like materials, very fine particles due to the purification mineral vegetable-based oil. Not recommended for the hydraulic system. 3 basic type of filter elements: surface of the edge and tap. The surface type of the element made closely with the woven fiber to treated paper. The oil flows through the pores of the filter material with the contaminator stop. The edge type filter is made with the paper to middle disc. The oil flows through the space between the disc and fineness, filterization, determined closeness of the disc. The type of the element is made of the thick layers, cotton felt, and other fibers. Accumulators. Like an electrical storage battery, the hydraulic accumulator stored with the potential power within the cave of the liquid or under pressure for the future conversion. Useful work of the work is included with the operation, cylinder fluid, motors, maintaining the required system pressure in case of power and power failure, compensation, pressure loss due to the linkage. Accumulators can be employed with the fluid, dispensed with the fluid, barriers can be provided, shock absorbent and cushioning action. On military equipment, accumulators usually mainly life equipment to provide with a positive clapping action, heavy loads, pump fluids, and diverter and lifting. Other operation accumulator acts to save the device to prevent the loading of it being dropped, indicate for the engine, pump of the failure, fluid leak. On the shift of the lifts of the other equipment, accumulators absorb shock with the result of the load starting and stopping and reversal. Spring loaded accumulator you with the sum of the engineer equipment, the hydraulic system, and you with the storage spring with the create with the constant force of liquid contained with the adjacent ram assembly. For your 215 show with the 2 spring load accumulated load character of the spring such that the energy stored depends on the force required of the compressed the spring. The free uncompressed length of the spring represents zero energy. Spring is compressed with the maximum installed length. Minimum pressure valve of the liquid from ram assembly stops liquid under pressure. Enters the ram assembly cause for the spring to compress with the pressure. Liquid will rise to cover the increased loading required to compress the spring. Alright, multiple springs. So spring and piston packaging, hydraulics to hydraulic system, spring, a single spring to hydraulic system, cylinder, ram assembly. Or your bag type of accumulator. Accumulator consists of a seamless high-pressure shell with a cylinder with a tray with a tube to end with a synthetic rubber with the bag with a separated liquid with a gas with nitrogen with the accumulator. The bag is fully enclosed with the upper end of the shell. The gas system contained with a high-pressure gas valve at the bottom end of the shell with a seal with a special plug with assembling containing liquid and pour. Safety features make it impossible to disassemble the accumulator with the pressure of the system. Bag is larger with the top of the tape, with the smaller with the diameter at the bottom. As pump force the liquid with the accumulator shell with the liquid presses against the bag, reduces the volume, increase the pressure with which is available to work. Piston type of the accumulator consists of the cylinder assembly with the piston assembly, 2 end cap and assembly with the cylinder assembly hose with the piston assembly incorporated with the provision securing the end cap assembly. And accumulator contains 2 floating piston with the liquid on one side with the piston with the pre-charge of the air with the nitrogen on the other system. Figure 217, page 216. Degree for the liquid volume with the degree for the gas volume and the degree for the gas pressure provided with the work potential with the liquid is allowed with the discharge. Maintenance before removing the accumulator with the repair with the remove of the internal pressure. Spring loaded type relieve the spring tension and the piston and the back type relieving the gas liquid pressure. Alright, show the gas valve, gas bag, shell, plug assembly, and liquid inlet, gas charging inlet, spring loaded check valve, normally open, that was the static position, now pre-charged position, fully charged, compressed gas liquid, alright, piston type accumulator, hydraulic liquid port, lubrication passage, piston assembly, barrel assembly, packing up and backing up ring, end of cap, and gas port. Our pressure gauge and volume measures. Pressure gauge are used with the liquid power system and the measure of the pressure. Maintain efficient safety. Operating levels of the pressure is measured from the PSI flow measure for the may express for the units of rate flow per gallons per minute or cubic feet per second. The may express for the terms of the total quantity with a gallon or cubic feet. Pressure gauge in figure 218 show the symbol pressure gauge readings indicate the fluid pressure set with the opposition force for the system. The atmospheric pressure for the negative negligible cover the action in one place for the balance equal action in another in the system. 218 show the pressure gauge of the right hand and pointer measure meters. Depending on the quantity, flow rates, type of the liquid involved, all liquids flow meters are measured with the measure. The specific fluids must be used only for the purpose of which they are made. Each meter is tested and calibrated. And the new aiding piston disc flow meter passes through the fixed volume measure of the chamber with the divided upper and lower compartments, and the piston disc, the figure 219, during the operation, one compartment is continually being filled with the others are being empty. As the liquid passes through these compartments, the pressure causes the piston disc to roll around the movement, and the disc movements operate in order counter through the gear elements to indicate what the column of the fluid is passed through the meter. Alright, show the flow register, intermediate gear train, spindle, stuffing box, outer housing, measuring chamber, piston disc, nutating piston disc flow meter. Alright, 2.8, portable hydraulic circuit test. The hydraulic power of the efficient method of developing horsepower pumping the fluid with the closest to the amount of flow that pressure unknowingly to decrease the amount of the horsepower to live with the working unit with a will reduced. System will not perform as a shoot. Tester portable hydraulic circuit test. Here's figure 220 lightweight unit that can have cover the trouble the hydraulic power system on the job of the maintenance shop. If the tester and system circuits determine if it's efficient correctly, several of the hydraulic circuit tests are on the market. Operating procedures may vary with a different tester, therefore must follow with the operating direction furnishing the tester. Check troubleshooting circuit accurately. Improper operation. Hydraulic systems not operate properly with the trouble. It could be one of the following. The pump of the propellant fluid may be slipping because of the one of the improper setting spring with the relief valve. The fluid may be leaking around with the control valve of the pass cylinder packing. Since the hydraulic system confined with the difficulty identified with the component of the system not working properly, measure the flow pressure, the temperature of the liquid, given points of the system to ensure that isolate the malfunction unit that does not work, take the system apart, check each unit, warm parts of bad packing. The type of the inspection can be costly. The standpoint of maintenance time and the downtime of the power system. 2.9, circulatory system. Pipe the fitting for the necessary seal for the make of the circulatory system liquid power. The equipment, proper selecting installation component with an important with properly selected install, the result would be serious, powerless, harmful liquid contamination volume list of some of the basic requirements of the circulatory system. Line must be strong enough to contain liquid and desired working pressure. Search of the pressure that may develop in the system. Lines must be strong enough to support the components are mounted on them. Terminal fittings must also be the junction where the parts of them must be removed with a prepared replacement. Line supports must be capable of the damping shock caused by the pressure surge. The line should be smooth in the interior to produce a turbulent flow. Lines must have the correct side with the required liquid flow. And figure 220 shows the portable hydraulic circuit tester portable type series. Lines must be kept clean. Regular flushing, purging source for the source of contaminant must be eliminated. 3 common types of liquid power systems are pipe, tubing, and flexible. Usually referred to rigid, semi-rigid, and flexible line. Tubing and types for the hydraulic line, seamless electrical weld with suitable for the hydraulic system. Seamless tubes are made larger sizes. Tubes than the electrical weld. The seamless tubes are flared and fitted in the thread with the compression fittings. Tubings bending easily so the fewer pieces of the fittings are required. Unlike the pipe of the tubing having be flared and fitted in the field, but the general tubing makes it greater, less costly, lower maintenance system with fewer flow restrictions and lesser chance of the linkage. Figure 221 shows the proper method of installing tubing. Now the following flow of flow type of the fluid with the velocity system pressure help determine the type of the types to be used. Nominal dimension tubing of the number of the fraction is the dash number of the representative of the tube with outside diameter OD and the 16th of an inch. The system pressure determines the thickness of the various tube welling. Tube above 1/2 inch outer diameter usually is installed with either fitting line with a metal pressure sealed with a welded joint. If the joints are welded, it should be stress relieved. Piping, you can use the piping thread with a screw fitting with the diameters up to 1 1/4 inch pressure is up to 1,000 psi with a pressure exceeding 1,000 psi required with the diameters over 1 1/4 inch pipe with a weld with a flange connection and single weld the size of the specified with the nominal inside diameter with the dimension of the thread remain with the same side with the given the pipe with regardless of the wall thickness of the piping is used. Economically large side with the hydraulic system, large flow with the care with the particularly with the suit, large with a permanent straight line with the piping tapered thread with the outside diameter of the tapped hole fitting. However, they cannot be bent and the self-fittings are used whenever the joint is required with the result of additional cost for the increased chance of leakage. Flexible hosing. Flexibility is necessary liquid power system used for the hose. Example of the connection of the unit with the move of the wall of the operation units are attached with a hinge portion of the equipment to the location subject to the sphere. Any vibration from the flexible hose with the connection of the pump of the system vibration that is set up. Operating the pump of the alternate cover of the rigid tubing and fail with the rubber hose. Flexible over the seamless synthetic rubber tube. Cover layers over the cotton braid with the wire braid. And figure 222 for the base 220. Show the cutaway view for the typical rubber hose. Air tube designed to withstand the material. Passing through over the braided with a well consists of several layers that determine the feature of the strength of the hose. The cover design with a tan and external Abuse. Installation flexible hose do not twist, do not reduce lift over the main house, cause fittings or loosen and identify the stripe of the running of the hose. There should not be spiral, it would be indicating the twisting of figure 223, protecting flexible over the shafting of the raping, lightly with the tape of the necessary with the minimum of the bend radius fire hose varies according to the side of the construction pressure for the which the system will operate. Consult the applicable publication contained with the table and graphs will show the minimum radial differential type of the insulation bend of the two show the relief of the bursting pressure of flexible hose considerable below the rated value. Install the flexible hose over the subject of the maximum of the flexible during the operation of the maneuver stretch the hose with the tighten between the two fittings under pressure flexible hose contract lengths and expanding with the diameter. Teflon type hose with the flexible hose is designed to meet the requirement of higher operating pressure the temperature of the two fluid type power system hose consists of the chemical resin procedure process bold and desired tubes. Show the bright on the top of the wrong on the bottom. Hard shape to cover the stainless steel wire over the braided over the tube with the string with the protection of the Teflon type hose with the absorb the moisture with the unaffected fluid tube with the today fluid power system non-flammable power. However, they use an asbestos fire sleeve with the wear power ability open flame exists. Careful hand all Teflon hoses during removal of the insulation sharp with the bending of the link of the damage of the hose flexible type of the hose with the form itself with the install of the position circulatory insulation system. Insulation flaring or brazing is most common method of connecting the tube between the tube of the insulation usually involve the cutting of the flange of the bending of the aft of the cutting of the tube of the correct length of the cut in square. Carefully remove all the internal and external burrs. If you use the flare type fitting of the move of the flare over the tube of the flare angle should be 37 degrees in each side of the center line out of the air that should extend beyond the maximum inside of the diameter, not the outside of the diameter of the flare is too short but the likely to squeeze thin, which will result in the leak of the brake with the flare is too long with the sticking the jamming during the assembly. Keep the line short and free of the bends if possible. However, the bends are the preferred the elbow short however bends are preferred to be elbows or sharp turns. Try not to assemble the tube in a straight line because the bend tends to eliminate strain, absorbing the vibration, compensating with the temperature expansion of the contraction. Installing all the lines, you can remove the without the dismantling of the circuit components, without bending with the springing of the bad angle for the end support of the line, with the frequent intervals minimize the vibration movement, and never while the lines to the support with sense to be flexible over the tendency to assure the subject of the pressure, allow enough slack to compensate for this problem. Keeping all the pipes and tubes fittings clean with the free of scale with the other form. Material clean iron steel pipe tubes fitting with a boiler tube with a wire brush with the commercial pipe cleaner. Equipment to remove the rust and scale the short with the starting pieces sandblasting along with no sand particle to remain long blended holes or pockets after flush beef with the cave of the long piece with the pieces bent. The complex shape of the remove of the rust scale with by pickling clean metal with a clean chemical bath with a K plug with the opening end of the pipe tube that will be stored for a long period. It does not use the rag waste the other purpose. Give the deposits with a harmful link can cause several damage in the hydraulic system. Fitting and connectors. Fittings are used to connect the unit to the fluid power. They include the individual section circulatory system and the different type of the connection available to the fluid power system. The type of the will be used depending on the type of the circulatory system, pipe of the tube with the flexible hose, fluid, medium, and the maximum operating pressure. Some of the most common type of the connectors are described below. Threaded connectors use some low pressure liquid power system, usually made of steel, copper, brass, with a variety of the design. Figure 224, 222, with the connectors made with a chain field male 3 cutting insides over the end of the pipe, 3 threaded outside male threads for connecting. Alright, shows the tailpiece coupling, closed nipple, long nipple, cross section, cap plug, ground surface, joint, tailpiece, reducing coupling, reducing bushing, T, 90-degree elbow return bend, and a 45-degree elbow. Sharing pipe threads tapered slightly to the tightness of the connectors to prevent the seizing of the threads sticking. Pipe thread compound threads keep the two ends of the three of the compound will contaminate the fluid. Pipe compound properly applied gets inside lines harmful. Pump for the container's roll and the equipment to fill air. Connect with the common, connect with the circulatory consists of the tube line with the connection. Provide safe the trunk with a dependable connection without having the thread or welded or soldered to the tubing connector. Fits a sleeve and a nut. See figure 225. Flared tube connector fitting nut sleeve tubing. Fittings are made of steel, aluminum alloy, or bronze. Fittings should be material with them similar to sleeve. And the tube of the fittings are made with 45 with a 90-degree elbow, tees, and various other shape. Figure 226 page 24 shows some of the most common fittings. Even flare connecting. Fittings are available in different thread combinations. Union of the tube connection with on each end. Elbows of the tube connection. One end male pipe thread, female pipe thread. Tube connection opposite end. Crosses, tees, and have several different combination tubes. With flare connectors must be flared being assembled with the nut fits in the sleeve of the tight and drawn with the sleeve of the tube fitting of the flare with the tight the male with the fitting of the form of the seal. The male fitting of the cone shape with the strip of the same of the angle of the inside of the flare with the sleeve support with the sleeve support with the tube, but the vibration does not concentrate at the end of the flare. Does distribute the shear action over the wider area with the added of the string with the tight tube nuts. Torque wrench value specified at applicable regulation. In aluminum alloy flare connector leaks after tightening specified torque. Do not tighten it further. The similarly connector with the correct fault with the steel connector leaks may be tightened 1/6 of the turn beyond the specified torque. An attempt to stop the leak of the unsuccessful disassemble or repair of flare connectors will leak of flares is stored into the nut thread sleeve of the crack of the flares cracked or split. Flares out around flares eccentric of the tube of the outside diameter flares inside rough and scratched. Flare cone is rough and scratched. Shows elbow flared 90 pipe 90 degree 45 degree elbow flared 90 degree flare tube pipe threaded outside. Flare tube on the on run, crosses, rare to flare tube, human flare tube, nipple flare pipe tube, union flare tube, bulkhead, universal elbow tube, bulkhead, 90 degree, universal flare tube, bulkhead and universal. Are threaded fitting not dirty and the damaged broken flexible hose coupling and assemblage. Similarly fabricated flexible like a field attachable code figure 227 with the use sample couplings. Fabricated replacement similar as long with a failure leak of the brake did not occur with a coupling failure occur with a coupling discarded. Measure for the replacement of the hose. Assemble the screw on the couplings. Measure for the edge of the retaining bolt. Figure 228. Place for the hose block with a bench vise for the figure 229. Front of the rear portion of the hook. Saw blade and cutting. If you use the middle portion of the blade, cut and twist the brake. After cutting and made with a sheath, should have 20 to 32 teeth per inch. Move the old coupling house of the assembly with a fabricated permanently attached coupling joint. Just discard the entire assembly. See figure 230, page 226. Alright, 227 show the field attachable coupling straight, 45 bent, 90 bent tube long dumping, 90 bent tube short drop. Reusable fittings to skid the tab of the figure 231, page 236. You must strip the skid of the hose of the length equal to the notch of the fitting of the end of the fitting. A notch of the same portion of the fitting of 231 indicates skid of the fitting to assembly connector with the skid fittings and measure of the edge of the hex. Length of the measurement, maintain the measure of the retaining bolt hose length, measure hose cutting, permanently attached couplings, skid setting, fitting, determine the length of the skid to make with a cut around the hose, the sharp knife, and make sure that you complete with the through the rubber cover of the hose. Cut the lengthwise end of the hose, lift the hose of the flap, remove the plier, repeat the process of the opposite end of the hose. Play with the female portion fitting of the bench 5 figure 233, secure it in place. Lubricate skid portion of the hose with the hose lubricant, hydraulic fluid, engine oil with the necessary insert of the hose female socket turn with the hose counterclockwise until the bottom of the shoulder. Female socket with the back off of the cord turn. Place female socket upright position. Figure 234, page 228. Inserts male nipple and female socket with the male nipple socket for 235, page 328. Until the X nine is 132 the inch of the female socket. Breed above process open and opposite end of the hose. When assembling conductor with a non-skid the type of the fluence valve of the bulb of the procedure out with the do not skid the hose. Non-skid fittings do not have the notch on the female portion of the fitting of the figure 236, page 238. Figure 237 the page 238 pie diagram A show of the female hosing on the end of the hose spiral ridge for the corset thread provides gripping action from the hose at the other end of the small end of the machine threads of the male fixed on the swivel and nipple with it inserted. Alright, Figure 237, the diagram show with the male adapter. Diagram C show with the male with a female swivel body fitting with a containing the swivel hex nut connector, one end with the opposite with a taper to machine thread with the mate with the thread end. Female fitting in the long taper insert with the hose with the screw, the female coupling with the taper. Show the trimming the hose and then the female porting portion of the fitting. Male female portions of the fitting, tightening the fitting. Non-skid fitting. Female hose coupling A, male adapter, male female swivel body fittings. Extended the opposite, expanding the hose, forcing again with the inside of the diameter female fitting. Figure 238 shows the assembly clamp type coupling. You for the coupling, do not skip the hose line. Skip the hose, lubricate the inside with the diameter of the hose and the outside of the diameter of the stem. Clamp the hose stem in the bench pipe and then install the hose, turning with that counterclockwise until the bottom of the begins with the shoulder of the stem of the diagram. If you do not have the device, force the stem into the hose, but pushing or striking the hose stem in a wooden block. Place the clamp halves in position. Paragraph 238, diagram B. Draw together with the device an extra long bolt, standard bolts to protrude with the far enough to grip the nuts. Remove the external extra long bolts, retaining bolts through the clamp. Tighten the nuts until you get them in the required torque. Figure 238, diagram C. Alright, note, you may have to retighten the bolts after the hose assembly has been operating with at least 10 to 20 hours. Clamping type couples, assemblies with diameters 1 inch or greater, reusable screw type fittings on a hose assembly diameters less than 1 inch. Leakage. Hydraulic system will usually have a certain amount of leakage. Any leakage will reduce efficiency, cover the power loss. Some of the leakage is built with a plan, some of the not. Leakage is internal, external, both. This type of internal leakage is not position built with a hydraulic component with a lubricating valve, spool, shaft, the piston, bearings, pumping mechanisms, the other movement part of the hydraulic valve of the pump, the motor for compensator converter controls leakage path of the built and provide precise control to avoid hunting, oscillation of spools and piston. Oil is not less than lost internal path leakage. Return to the reservoir with the return line special provided drain passages. Too much internal leakage will slow down the actuator power loss to company, but the heat generator leakage patch. Some instances of excessive leakage valve could cover the cylinder drift and even creep the valve with the support supposedly in neutral. In this case, the flow and the pressure control valve leakage can often reduce the effective control, even control to be lost. Normal wear crease of the internal leakage would provide large flow paths with the leakage oil. With the oil low in viscosity leaks more readily with a heavy oil. Therefore, oil viscosity index is important consideration preventing internal leakage. Internal leakage can also increase the pressure. Just as high pressure causes with greater flow through an orifice. Operating area recommends pressure adds with the danger of excessive internal leakage with a heat generation with the other possible harm effects. Blown ruptured internal seal can open large enough that the leakage part of divert all of the pump delivery that happens in every except for the oil flow and heat generation. The leakage points and stop. External leakage B has with expense with the unsightly with the fault with the insulation port made in the primary cover. The external leakage joint made with because the joint leaks because they were not put together properly because of the shock of the vibration line shook them loose. Adding support of the line prevents this that some of it is installed with the car actually components seldom leak out with the failure to connect with the drain lines except for the pressure. Contamination can cause the bloat or damage result of the external leakage with the components. Alright, prevention, proper installation, controlling of operating conditions, proper maintenance, and help with any event leakage, installation piping, the tubing, control with the manufacturer recommendation, promote the long life of the external seal with the vibration strength of the result of improper installation, and shake loose connection, create puddles, void pinching, cocking, incorrectly installing seal with assembly of the units, use any special tools of the manufacturer recommendation, installation, seals, operation conditions, show the correct seal life with the must control with the operating with the control of the equipment, shaft seal with the point with the piston, reseal with the exposed with the moisture and salt with the dirt, any other abrasive contaminant with a short lifespan. With also the operator should be always trying to keep the load with the recommended limit to prevent leakage caused except for the pressure. Maintenance, regular filter for the oil change for the high quality of the hydraulic oil, seal life with the inferior oil, where with the shield and interfere with the disappearance of the oil, operates proper maintenance, prevent the impurity deposit with the circulation and ingredients that could wear with the dynamic seal. Never use the additives without approval of the equipment and oil suppliers. Lubricators will critical seal life with the dynamic application synthetics and absorb the much oil must be lubricated quickly where they will rub leather and fiber do not absorb oil. Manufacturers recommend soaking seal over in oil before installing it. Overnight before installing it. Do not install a seal dry, always coat it with clean hydraulic oil before installing it. Seals are packing material that use to prevent leak of the liquid power system. Seal is a gasket of the packing seal, bring other part of the design specifically for the sealing. Application usually static dynamic depending on the part of the seal moved in and the relations of one another. Seals keep the hydraulic oil from passage with a whole pressure. Uniform pack materials getting in the hydraulic pass to prevent leakage. Sealing, positive sealing method involved with the actual sealing of the material parts and material with the hydraulic components to be the non-positive sealing, leakage, lubricant fitting parts closely together to shrink the oil film on the power slide against to provide effective seals. Static seals. Pipe thread of the seal string with the tube of the valve within caps of the seal with the non-moving part of the static movement. Gasket seal with the static seals opposed. Used to make a connection between components and the static seal gasket is placed between the parts. Not move in relation to the other. Shown in figure 239 shows some of the typical static seal flange connections. Gasket, simple tongue and groove, metal to metal joints. Dynamic seals. Dynamic seal application either reciprocal or rotary motion curve between the two parts. Example: the piston, the bar, or rear seal, hydraulic cylinder, drive shaft, pump and motor, no pressure. Alright, the O-ring in figure 240. For the O-ring, pops the seal that you the tag dynamic application that has placed on the flat gasket hydraulic equipment to be installed with the O-ring is screwed to the top of the bottom and groove again for the mating of the part of the capable of sealing the very high pressure of the pressure of the force against the side over the groove as a result of the positive seal with the three side with the dynamic application. O-rings are usually limited reciprocating part for the half a blade of relative short motion. To remove the O-ring seal, you need to use a special tool to remove the top of the aluminum and the brass rod. Make sure that the tool's edge is flat and that you polish the main with the burn of rough surfaces. Right, 240 shows O-ring placement, no pressure and pressure. Backup ring, figure 242, page 32, usually made of stiff line. You can use the backup ring and O-ring so that it's not. Force and space over the mating part of the combination high pressure clearance between the part of the could call for backup ring. Or your lathe cut seal with a seal like an O-ring, but a square cross section rather than round. The lathe cut ring is extended over the tube of the O-ring must be individually molded and make a static application around with a square section. Seal with the interchangeable made with the same material. The T-ring seal with the seal. Reinforced backup ring with the A-T ring seal is used with the precipitating dynamic application, particularly with the open cylinder position. Lip seal, figure 244, dynamic, the mainly open rotating shaft sealing provides positive seal against low pressure lip, then install with the forward pressure against the lip balloons and out with the aid sealing, the very high pressure out with the cannon pass, the kinds of the because it does not have backup support O-rings. 241 O-ring removal tool, surface may be smooth with free surface. Corners must be not dented or bumped. 5,000 inch radius flat and are shown in position of the bird's edge. Sometimes double seals are used in the shaft with reversible pumps and motors. Reversing the unit can alternate pressure vacuum condition clearance. Chamber adjacent double lipping seal with therefore that prevents oil from getting out of the air and air getting in it. Cup seal, figure 245 of the pop seal with the hydraulic cylinder piston seal is much like with the lip seal with the cup seal with the back backed up so that handle very high pressure. So O-ring pressure, backup ring, piston ring, figure 246, piston ring, use the seal pressure, and with the reciprocating piston, helps group friction, minimum hydraulic cylinder, offer really resistant movement. The cup seal, piston ring, used in many complex bone systems to seal fluid past the leading of the follow rotating. Alright, so I showed you the seal and backup ring of the T-ring seal, lip seal, seal housing, spring lip, high pressure, a cup seal, cylinder cup seals, position, piston ring, seal ring, cylinder barrel. Alright, shafts and fine with a high pressure may not provide positive fuel. Positive fuel more likely will occur with the piston rings in place side by side. The piston ring is designed to allow the leakage of the lubrication. Face shield, figure 247 on the page 234. The shield has two smooth flat elements that run together. The shaft, rotating shaft, one element metallic, other non-metallic elements are attached to the shaft of the body with one face stationary, the other turns against it. One element spring loaded with the take of the wheel with the face seals used primarily with the high speed, pressure, and temperature. Packing. Packing type of the twist of the wood with the foam to soft the metal strands that are branched between the two parts to seal with the packing gland. Support with the packing up with the backing. The backing for your 248 can be either static or dynamic. It has been used with the rotating shaft seal with the reciprocating piston rod seal with the gasket. Many steel application. Static application seal replacing or packing compression packing is usually placed in the coil layered and bore and compressed tight and flange member. A molded packing is bodily molded precise cross sections such as a U or V and several. Packings can be used together in the backup with a spring load with the compensate with the wear. Sealing materials. Earliest sealing materials of the hydraulic components were mainly leather and cork impregnated fibers. Currently measuring most sealing hydraulic systems made synthetic material with nitrile, silicone, and neoprene. Leather seals. Leather is still good, but the sealing material that have not completely replaced the elastometer for the tough to resist the abrasion, have the ability to lubricate fluid into fibers, impregnating leather. Synthetic rubber improve the leather with a sealing ability, producing friction. Leathers disadvantage or tend some to squeal and would dry and cannot be stand high temperatures. It shows the face shield with a housing sealing face, preloading spring, high pressure shaft and low pressure. Figure 248 shows the compression, packing, and pressure. Nitrile seals are comparable to tough material example. Excellent wearability, composite variable compatible. The petroleum oils can easily be molded with different seal shapes. Some of the nitrile seals used without difficulty. Temperature ranging from negative 400 degrees, 140 degrees Fahrenheit to 230 degrees Fahrenheit. Silicone seals will last so meet with a much wider temperature of the range that some of the nitriles have, but the silicone can be used with a reciprocating seal to cover the time enough. If the seals elongated, braid with a fairly even, the many live type seal may be silicone used with extreme temperature application. Silicone O-rings use static application. Silicones have the tendency to swell with an absorbance of the fair of the volume oil ring running hot. There's advantage of the swelling with a non-objection because the seal can run dry with a longer time start up. Neoprene, a very low temperature neoprene compatible with petroleum oil, allowing 150 degrees with a habit of cooking and the volcanizing, making it useful. Nylon is a plastic also known as fluoroelastomer with a combined fluorine with a synthetic rubber to use with the backup. Ring sealing materials and special applications have very high resistance. Chapter 3, Pumps.